Good afternoon. Or good, I'm being sarcastic. Good morning. How you doing?
Chelsea.
Glad you're here.
I
All
said
right, so ladies and gents, Algebra 1 for anybody who this is your first day. The class code is here if you haven't entered on Summit. So write down the class code and you can enroll in the class at your earliest convenience. I have made some assignments, so to do it sooner than later would be best. All right, so today we are talking about data representation, and our objective is to represent data in a graphic way. That just means we are given a data set and we are going to put it in a graph. So we've had our community meeting. We are going to review box plots. We're going to practice finding the 5-number summary from a box plot, and then we are going to look at the second cool down. All right, so here we go. So again, my favorite entertainer, that's my Gladys Knight. So now, we talked about a box plot on Monday. And a box plot, some of you may remember it from middle school as a box and whiskers. And again, it is a 5-number summary of the data. The ends are the maximum value of the data set and the minimum value of the data set. So you got your minimum and your maximum. Now, the box is made up of medians. You have in the middle will be the median of the data set. The median of the data set splits the data into a lower half and an upper half. Okay? So then you will find the middle of the lower portion of the data. Then you will find the middle of the upper portion of the data. So in that box will be 50% of your data. And the Q's stand for quartiles because, as you see, the data is in 4 parts. So 25% is here, 25% is here, 25% is here, and 25% is here. Okay?
Just so you know, I can't see your screen.
You cannot?
At least I can't see it. I don't know if others
Okay,
can.
wait a minute. Let me, wait, hold it. I thought okay. I don't know what happened. Thank you. Oh, can you see it now?
Yes, thank you.
Okay, thank you. All right, and I'm saying here. Okay, so these are the 5 steps we laid out. We will always put the data in numerical order. Again, then we identify the minimum value, the maximum value. Then we find the median of the data set. That goes in the middle because this shows the middle of the data. So now the data is broken into 2 parts, the lower piece and the upper piece. We then find the middle of the lower piece. We then find the middle of the upper piece, and that creates our box. So our box is a box of middles, the middle of the low end, the middle of the data set, and the middle of the upper end. That forms our box, and that's 50% of our data. Because then here's the other 25 on the whisker, and here's the back 25. Okay, so a box plot is a 5-number summary. And then when we just speak of the box itself, the box can tell us how far or the range from the middle of the low end to the middle of the high end. And that is called the inner quartile range. inside the quarter range. How far is the middle of the low end of the data from the middle of the high end of the data? So those of you who were not here, I would ask that you write down the 5 steps and you write down the diagram. Now, you can also take a screenshot of this. To screenshot, you would hit the control button and you will hit the button over the number 6. It looks like a rectangle with 2 lines. That will screenshot what you see. Now, here is an example. So, given this data, 3, 7, 8, 5, 12, 14, 21, 13, 18, we are going to create a box plot. So first, put the data set in numerical order. Now, all of mine is coming at one time. So, the first line, we put the data in numerical order. That doesn't make sense. So, oops, wait a minute. Excuse me. I need to go back a slide. Because the minimum value is not 2, it is 3. Oops. And I apologize for that. All right. Now let's go back. Okay, so the minimum value is 3. The maximum value is 21. 2 of the 5. Now we find that we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Because we have 9 terms, we can physically find the middle. If we come in 4 from the left, come in 4 from the right, we have 12 sitting in the middle. So that 12 is the median of the data set. So that 12 has just divided the data into 2 parts. So now, with 12 being the median of the data set, we now have broken the data into 2 parts. This 3, 5, 7, 8 is the lower half of the data. And 13, 14, 18, 21 is the upper half of the data. So now we are at step 4, the middle of the lower end. We have 4 terms. How do we find the median when we have an even number of terms? What do we do?
See that again?
If we have an even number of terms, how do we find the median?
Don't you don't you subtract something?
Nope, don't subtract. That's the range.
Oh yeah. You just don't you cross them out?
Yeah.
Or something?
I hear somebody saying it in the background.
Middle numbers and then divide it by the numbers that you have. How many numbers?
Yes. So, ladies and gents, when you have an even number of terms, you add the middle, you take the average of the middle 2. So you add the middle 2 and divide by 2. So this 6 5 plus 7 divided by 2. So to find So to find the middle of the lower end, we added the middle 2, 5 and 7, and divided by 2. 5 plus 7 gave 12. 12 divided by 2 gave 6. So that is the middle of the lower end. And then we did the same thing in the 5th step. We are looking for the middle of the upper end of the data, and we have to do the same thing. There are 4 terms. We will add 14 and 18. 14 and 18 is 32. 32 divided by 2 is 16. So now we have our 5-number summary. We have the minimum and the maximum. We have the median, which is the middle of the entire data set. Then we have the middle of the lower half and the middle of the upper half. Now, we talked about placement. Because the median of the data set, our Q2, is closer to the median of our upper half versus the median of our lower half, when we make our box plot, we should have Q2 closer to Q3. So placing Q2 down here, that would not be the proper graph or box plot of the data set. Again, the median of the data set is closer to the median of the upper end of the data, so you should put it there. Okay? And the same thing with 3 and 6. Between the minimum and the middle of the lower half is 3 units. So that can be short. Whereas the distance between the middle of the upper portion of the data and the maximum are 5 units away. So that whisker should be a little longer. Okay? And then the interquartile range, the IQR, the upper end minus the lower end. Now, this is not mathematically correct. You should only have one set of equal signs, but just for our demo. So the interquartile range is 10. So that means that the range between, or the distance between the middle of the high end and the middle of the low end is 10. Okay? And we'll use that a little later on. So now, that might have been a lot, but let's practice that. So let's look at this box plot. This is the practice. So I asked you all to bring paper. We are looking for the 5 numbers that will be in the summary of this box plot. So again, remember, first, put them in order, numerical order. Then identify the minimum value, the maximum value. Q2 first. What is the middle of the data set itself? The median. And once you have the data split in half, find Q1, the middle of the lower half, and then Q2, Q3, the middle of the upper. So I have 11, 11. I'm going to give you till 1/4 after. So I'm going to give you about 4 minutes, 5 minutes. Let's see what we can do. Is that right? Okay. So we got, all right. So that will go in there. All right, I'm gonna have to do this one on my board. All right. All right, ladies and gents, I'm gonna stop sharing so that we can do the work. Okay, so from the data set, can you see my board?
Yes.
Yes. Okay. All right. So from the data set, to put them in numerical order, check your paper. 89, 92, 93, 94, 99, 100, 107, 111, 119, 125. So that was in numerical order. So from that, off the top, we can identify our max and our min. So we know our max is 125 and our min is 89. So boom, boom. That's our max and our min. So now, let's talk about the math part. So remember, we find the middle of the data set first. So we find Q2 first. So our Q2, first of all, how many terms do we have? Somebody.
10.
10. Yep. So since we have 10, what are we going to have to do?
Add 99 plus 100, then divide it by 10.
Exactly. So we have 10 values, even number. We came in 5 from the left, 5 from the right. We're going to add them together and take the average. So we have 199 divided by 2. Calculators. What you got? Life is not in whole parts.
It's 99.5.
Thank you. So this is 99.5. Now, here is what I want you to watch. That means that 99.5 is in between. It is not on the graph. However, you gonna write it because that's how your graph is split in two. Because if you don't put in 99.5, your Q1 and your Q3 aren't going to be correct. So when you put in 99.5, guess what? Now on your low end, you have an odd number because you have 89, 92, 93, 94, and 99. So in your list of data, I want you to put that arrow and put 99.5 because that is the middle of the data. So now for your Q1, life just got beautiful because in Q1, you are only considering 89, 92, 93, 94, and 99. What is the middle? So your Q3 pops out beautiful. Okay? And then your upper quartile, you are considering 100, 107, 111, 119, and 125. And again, the median pops out real beautiful. So on your graph, your Q1 is 93. Your Q2 is 111. And our Q2 is 5.5 from 93. No, excuse me, 6.5 from 93 and 10.5 from Q3. So our Q2 should be closer to Q1 than it is to Q3. So our Q2, we're going to put somewhere in here, and that is 99.5. Okay, so then we can draw our, we can draw our whisker. Boop. Again, distance between here and here is 14. The difference between here and here is 4. So this whisker should be shorter than your upper, oh, excuse me. The lower whisker should be shorter than your upper whisker. Because again, the distance between the minimum value and the middle of the lower portion of the data is closer together than the middle of the upper end of the data and the maximum value. Did that make sense?
Yes.
And again, if you need to write down the math, I will back up enough for you to do the same. Sorry. All right, you all are good there? All right, now I'm gonna stop the record. We